The day we left Earth, there was no grand ceremony, no soaring speeches from world leaders standing before cheering crowds. The crowds were gone, either already on their way or lost to the chaos. Instead, there was just a single automated broadcast. It looped every hour, a final message from a dying world. The image was grainy, transmitted from the last operational satellite. It showed the Pacific Ocean, but it wasn't the brilliant blue we remembered. It was a murky, toxic brown, choked with algal blooms that had starved the water of oxygen. The continents were scarred, vast deserts creeping over what were once green lands. The message was simple. It was a data packet containing humanity's history, our art, our science, and a final, somber farewell. For those of us on the ships, watching it on our small cabin screens, it was a profound and deeply sad moment. The decision to abandon Earth wasn't made in a day. It was the conclusion of a long, painful process of realizing we had passed the point of no return. The primary culprit was the climate. We called it the cascade. It started with the oceans. As they warmed, they became more acidic, dissolving the shells of the plankton that formed the base of the entire marine food web. The great fisheries collapsed, not from overfishing, but from starvation. Then came the superstorms. Hurricanes that made old Category 5 storms look like gentle breezes. They didn't just hit the coasts, they pushed miles inland, turning cities into saltwater swamps. Then the land began to fail us. The predictable seasons our agriculture had relied on for millennia became a chaotic mess. Decades-long droughts turned breadbaskets into dust bowls. The American Midwest, the Ukrainian plains, the Fertile Crescent, all of them withered. When the rains did come, they were torrential downpours that washed away topsoil and caused flash floods. We tried to adapt. We built seawalls, developed drought-resistant crops, and constructed vertical farms in the hearts of our cities. But it was like trying to patch a bursting dam with chewing gum. Once the decision was made, humanity finally did what it does best under pressure. We united and engineered our way out of a corner. Project Ares was the largest and most ambitious undertaking in human history. It made the Manhattan Project and the Apollo program look like high school science fairs. Every major nation poured its remaining resources, its best minds, and its last hopes into one singular goal: building a fleet of interplanetary arcs capable of transporting nearly 1 million people to Mars. The preparation was meticulous and brutal. First came the robotic waves. Hundreds of missions were launched to Mars years ahead of the human fleet. These probes and rovers weren't just for exploration. They were construction crews. They deployed solar arrays, 3D printed basic habitat shells from Martian regolith, and drilled for subterranean ice. They scouted the safest and most resource-rich landing sites, focusing on the vast lava tubes near the equator, which could provide natural protection from radiation. Next came the selection process. How do you choose who gets to go? It was a logistical and ethical nightmare. Ultimately, it was a lottery, but a weighted one. You had to be healthy, with no chronic illnesses that would be a drain on limited medical resources. Your skills mattered. We needed engineers, doctors, geologists, agronomists, and technicians of every stripe. But we also needed artists, musicians, and historians, people who could carry the soul of humanity, not just the technical knowledge. The launch was not a single event, but a staggered exodus over several months. The Ark ships, too large to ever land on a planet, were built in orbit. Ferries, essentially reusable single-stage to orbit rockets, carried passengers and final cargo up from Earth's surface. The view from the ferry window was a gut punch. You could see the planetary-scale damage with your own eyes. The brown oceans, the smoke plumes from continental fires, the unnaturally large deserts. It was a funeral procession, and we were leaving our own mother's casket behind. Once docked with an Ark, we were assigned to our cabins and our roles. The journey had begun. We were falling toward Mars. Life aboard the ship was a strange mix of monotony and purpose. The rotation of the habitat ring provided about 0.8 G, not quite Earth's pull, but enough to feel grounded. Days were strictly scheduled. Everyone had a job. Some monitored the ship's life support systems. Others tended to the hydroponic bays, and there were training drills for Martian arrival. Arrival was the most dangerous part of the entire mission. The Ark ships didn't land. they entered a stable orbit around Mars. Then we boarded smaller, purpose-built landers, the Mars descent vehicles. These were cramped, rugged craft designed for one thing: getting through the thin Martian atmosphere in one piece. The descent was terrifying, a fiery plunge through a pinkish sky, buffeted by winds, with the retro rockets screaming to slow us down. Then, with a final jolt, we were down. The silence that followed was absolute. We had made it. We were on Mars. Our new homes were not the gleaming biodomes of science fiction. They were far more practical and safe. We established our primary settlements inside massive ancient lava tubes. These subterranean caverns, some hundreds of meters wide, offered a pre-built solution to Mars's biggest threats: radiation and extreme temperature swings. Underground, the thick ceiling of rock provided natural shielding. The temperature inside the tubes was a stable, albeit chilly, -30°C. Inside these vast caves, we built our habitats. The initial structures were inflatable modules brought from Earth. As the colony grew, we used 3D printers and Martian regolith to build more permanent, rigid structures. We carved out community halls, workshops, and private apartments. The streets of our city were the dusty floor of the lava tube itself, illuminated by strings of powerful LED lights that mimicked a day and night cycle. Food production was the cornerstone of our survival. We couldn't rely on resupply from a dead planet. Our lives depended on our ability to grow our own food. We constructed large, multi-level hydroponic and aeroponic farms within the lava tubes. We grew high-yield crops: potatoes, soybeans, wheat, lettuce, and tomatoes. Water was our most precious resource, extracted from the subterranean ice deposits our probes had found. Every drop was meticulously recycled. Waste from the habitats, both human and organic, was processed in bioreactors to create fertilizer for the farms. It was a perfect closed loop. Living on Mars meant accepting that the planet itself was actively hostile to human life. The challenges were relentless, woven into the very fabric of the world. The first and most obvious was the atmosphere. It's incredibly thin, less than 1% the pressure of Earth's, and composed almost entirely of carbon dioxide. You couldn't just walk outside. Stepping onto the surface without a pressurized suit would cause your blood to boil in seconds. Then there was the cold. Mars is a frozen desert. Even at the equator on a sunny summer day, the temperature might reach a balmy 20°C, but at night, it would plunge to a deadly -73°. This extreme diurnal temperature swing put immense stress on all our equipment. Metals became brittle, seals could fail, and power consumption for heating was a constant concern. Our surface rovers, solar panels, and scientific instruments had to be engineered to withstand these cycles day after day. The Martian dust, or regolith, was another pervasive menace. It was finer than sand, almost like flour, and electrostatically charged. It clung to everything. It got into the joints of machinery, abrading seals and clogging filters. On EVAs, it coated our suits, and despite our best efforts to clean them in the airlocks, some of it always found its way inside. Finally, there was the radiation. With no global magnetic field and a thin atmosphere, the surface of Mars is constantly showered with high-energy particles from the sun and deep space. Faced with a planet determined to kill us, we had no choice but to innovate. Our survival depended on our ability to outthink the environment. To solve the atmosphere problem, we didn't just rely on suits. We began the monumental task of atmospheric processing. The MOXIE experiment, first tested on the Perseverance rover, was scaled up massively. These machines, essentially artificial trees, inhaled the carbon dioxide-rich Martian air and split it into carbon monoxide and breathable oxygen. To combat the cold and the dust, our engineering had to be robust and clever. For power, we used a combination of technologies. Vast solar farms were laid out on the surface, but they were designed with mechanisms to vibrate the dust off or be cleaned by autonomous robots. During the long nights and planet-wide dust storms, we relied on the steady, reliable power from compact nuclear fission reactors. These were buried deep underground for safety, providing the baseline energy needed to run life support and heaters. The solution to the radiation threat was to stay underground, but we also worked to turn a liability into an asset. We mined the Martian regolith for its constituent elements. We extracted iron for three-dimensional printing metal parts and building materials. We found pockets of water ice, not just for drinking and farming, but to be split into hydrogen and oxygen for rocket fuel. This in situ resource utilization was the key to becoming self-sufficient. It meant we could build, repair, and even expand without needing anything from Earth. We were learning to live off the land, even if that land was a frozen, irradiated desert. The planet provided the raw materials. Our ingenuity provided the means to use them. Even as we built our new lives on Mars, the ghost of Earth haunted us. It was a collective, unspoken grief that hung in the recycled air of our lava tube homes. We had a digital archive of everything: photos, videos, sounds of our old world. But accessing it was like looking at pictures of a loved one who had passed away. We could see the Amazon rainforest in stunning high definition, but we couldn't smell the damp earth after a rain. We could listen to recordings of ocean waves, but we couldn't feel the spray on our faces. The sensory memories were the most painful. The smell of freshly cut grass, the taste of a saltwater sea, the feeling of warm sun on bare skin. These were gone forever. This profound sense of loss manifested in different ways. Some colonists became obsessed with the archives, spending their free time immersed in the digital ghost of Earth. Others couldn't bear it, and avoided the archives completely. A new form of art emerged, one that tried to capture the feeling of this loss. Music with haunting, empty soundscapes. Paintings that contrasted the vivid blues and greens of Earth with the stark reds and ochres of Mars. We called it solastalgia, a term from old Earth that meant the distress caused by environmental change. For us, it was the defining psychological condition of our generation. The children born on Mars, the Martians, experienced this differently. They had no direct memory of Earth. For them, it was a myth, a fairy tale world of vast open water and breathable air. We tried to cope by creating echoes of Earth. In the largest biodomes, we built parks with real grass and trees, carefully cultivated from our seed banks. These were our most sacred spaces. Despite the hardships and the ever-present grief for our lost home, there was a powerful sense of hope on Mars. It was a gritty, hard-won optimism forged in the face of overwhelming odds. Every day we survived was a victory. Every new crop harvested, every successful expansion of the habitat, every child born healthy under a red sky was a testament to human resilience. We had been knocked down, our species brought to the very brink of extinction, but we had not given up. We had crossed the void and set down roots in a new world. The future of humanity was now inextricably linked to Mars. Our long-term goal was ambitious, almost audacious, to terraform the planet. It was a project that would take centuries, perhaps millennia. We began the first small steps. We released extremophile bacteria and lichens on the surface, organisms engineered to survive the harsh conditions and slowly begin producing oxygen. We debated grand schemes of melting the polar ice caps to thicken the atmosphere and warm the planet. It was a dream for our distant descendants, a multi-generational project that gave us a shared purpose beyond mere survival. We were no longer just refugees. We were the gardeners of a new world. Our society on Mars was different and perhaps better than the one we left behind. The divisions that had plagued us on Earth, nationality, race, religion, seemed petty and insignificant in the face of our shared struggle. You didn't care where the engineer who maintained the oxygenator was from, only that they were good at their job. We were simply humans. This new, unified culture was our greatest strength. We were building a civilization from the ground up, with the chance to learn from our past mistakes. We could create a society based on cooperation, sustainability, and a deep, abiding respect for the fragile environment that kept us alive. The future on Mars is uncertain. It will be a long, difficult road. The planet will continue to test us. We may fail. But for the first time in a long while, humanity has a future. It's a future written not in the blue and green of Earth, but in the red dust of Mars. It is a story of a species that stared into the abyss and chose to build a ladder. We carry the memory of Earth as both a treasure and a warning. We are the children of a world we destroyed, tasked with building a better one. Here, on this cold, distant planet, under the faint light of a faraway sun, we have found our last, best hope.